Okay, good afternoon, everyone. Welcome to this session on balancing net zero and other environmental objectives. I'm Andrew Lovett from the University of East Anglia, and I'll be acting as the chair for this session. By way of a little bit of context, here's a couple of quotes from the net zero strategy. So we're talking about in this conference the sort of the implementation issues and some of the challenges. So the net zero strategy recognises that delivering net zero can create opportunities to benefit other environmental objectives. And it also, for instance, talks about the idea of managing land use change in a systematic, geographical, targeted way with governance and delivery structures. So all things we've been hearing about a lot during this conference. The challenge is that there's much less in the strategy about how you're actually going to try and achieve this sort of integrated assessment and planning. And for instance, this is one of the things that's highlighted as a gap by the Committee on Climate Change in their review of the strategy. So that's very much the context for the session this afternoon. So what we're going to try and do is examine some of the issues and methods involved in achieving a closer integration. And we're going to draw upon examples from the UK and also from Germany. And there's going to be 3 presentations, and then we'll have the panel up on the front at the stools to go through the various questions. So we're going to have 3 presentations. So Gemma Delafield and Brett Day from the University of Exeter will talk about work looking at how you might integrate and assess some of these issues in the terrestrial environment context. Nikki Beaumont from Plymouth Marine Laboratory will talk about some of the issues in the marine environment. And Christina von Haaren from Leibniz University, Hannover, will talk about some of the work that she's been involved in doing in Germany for the federal government and state agencies, looking at environmentally compatible energy transitions. So I hope it will be interesting, and I hope it will give you lots to think about. So without further ado, can we move on to Gemma?
Hello everyone, my name is Gemma Delafield. I'm a postdoctoral researcher based at the University of Exeter, and I'm going to be doing a bit of a double act with Brett today on our presentation. So I'm going to be talking to you about some of the research that I did during my PhD, looking at the development of a spatially explicit optimization model to explore the land use implications of different energy futures. So as Andrew has just alluded to, not only do we need to meet the ambitions of net zero and reducing greenhouse gas emissions, we also need to ensure that we're incorporating the value of nature into energy decision making. And the government's 25-year environment plan stated that we need to leave the environment in a better state than we inherited it. So the key part of my research focuses on this question of how do we meet these kind of energy and environmental goals simultaneously? How can we site energy infrastructure in locations that avoids kind of adverse environmental impacts, for example, siting wind farms on peatlands potentially, and maximise the kind of environmental co-benefits we can get from, for example, siting bioenergy crops in areas that can have positive outcomes for biodiversity and water quality, that kind of thing. So I'm going to briefly give you an overview of the Advent NAV model. It's the model that I've been developing with many colleagues, many of whom are actually sat in this room today, and some of the results from my PhD. So the Advent NAV model is a spatially explicit optimization model. We split the whole of Great Britain into 1 kilometre cells, and we have lots of spatial information about each one of these 1 kilometre cells. So we know things like the land cover, wind speed, foregone agricultural costs, this kind of thing. And we can therefore ask the question of how much would it cost to locate either a wind farm, a solar farm, a bioenergy power station, or grow bioenergy crops in each one of these 1 kilometre cells. And we're actually expanding this in my postdoc to consider offshore wind, which Nikki's going to talk about, and Brett will talk a little bit about how we're incorporating BECCS into the model as well, so bioenergy with carbon capture and storage. So essentially, we look at the costs associated with these three technologies in every 1 kilometre cell in Great Britain. We consider the market costs, so we consider things like how much would it cost to construct the infrastructure in each one of these cells, what would it cost to connect it to the grid, what would be the foregone agricultural production associated with taking land out of agriculture and using it for energy generation instead. We consider operation and maintenance costs. When we consider BECCS, we consider the CCS network, and we also consider the transport costs. So, for example, getting the bioenergy crops from the field to the power station. And I should highlight the bioenergy crops that we consider are miscanthus and short rotation commerce. So the novel aspect of the Advent-Nev model is the fact that it also considers non-market costs. So by this, I mean ecosystem services. So we're able to quantify and monetize these ecosystem services where possible. So we've incorporated how the land use change associated with renewable energy infrastructure will impact things like visual amenity, carbon sequestration, greenhouse gas emissions, water quality, flooding, and pollination. And we're also working, well, Brett's been working on bringing recreation into the model too. So the key thing that the Advent-Nev model does is it takes an existing energy pathway. So for example, this is one that came out of some UKIRK work done back in 2018. So this is a low carbon without CCS pathway. We take this, so we say how much wind, how much solar, and how much bioenergy do we need? And what the Advent-Nev model looks at is, well, where would you locate that energy infrastructure within the UK to deliver the energy system at the least cost? So one of the key messages that came out of my thesis and the work that I did during the Advent project was firstly that you can actually start to consider how different energy scenarios look from a spatial point of view. So these green dots, those are bioenergy crops. The little diamonds, which, sorry, quite hard to see from this scale, are the bioenergy power stations. The blue dots up in Scotland are wind farms, and the yellow dots predominantly along the south coast are solar farms. So this is the spatial distribution of the energy infrastructure if we just consider market costs. And that's just a little zoomed in photo for you. But if we also bring ecosystem services into the decision making, we can see that the spatial distribution of this energy infrastructure changes, right? We see in particular bioenergy crops moving much more into central England, into southeast England, northwest England, this kind of thing. So the key driver of these changes is the fact that bioenergy crops are being located to areas of land that can have carbon sequestration benefits, can reduce greenhouse gas emissions, things like that. Those are the key drivers. We see wind and solar moving away from locations that have kind of high visual disamenity. So this is kind of linking back to the session that we just had on bioenergy, if people were there. So actually really beginning to understand what could the scale of land use change for these bioenergy targets look like. And then we're able to quantify these market and non-market costs. So you can see here, when we only consider market values, we get this non-market cost of £6 billion. So essentially £6 billion of adverse environmental impacts. Whereas if we include ecosystem services in the decision making, we can result in £2 billion of ecosystem service benefits. So we're kind of showcasing here that the kind of social cost of the energy system can be reduced if we bring ecosystem services into decision making. Another kind of key output from the work that I've been involved in is, again, looking at the scale of land use change. So Rebecca was talking about 700,000 hectares of land use change in the previous session. Some of the results that I've been looking at that have been taking kind of the CCC's bioenergy targets show that we could actually see potentially a lot more land use change depending on the kind of assumptions that you're making around yield and this kind of thing. So this map here, so the purple shows kind of a low bioenergy expansion. If you add on orange, that's a media expansion. And then with the green, as you can kind of see, that's a really high bioenergy pathway. But these are the kind of pathways that are being considered by the CCC. And the second thing that I've been looking at, and a paper that I'm hoping to submit next week, is looking at the implication of adding spatial restrictions. So we've talked about in the past how to try and avoid kind of conflicts with the environment, we might exclude energy infrastructure from areas like national parks, areas of outstanding natural beauty. We might exclude it from high quality agricultural land, so agricultural land classifications 1 and 2. And as you can see, when you consider different kind of restrictions, where you locate this bioenergy crop changes. So you're moving to locations that have a lower yield and therefore have higher costs. And the spatial footprint of the energy system also increases because you're kind of taking out land that might be highly productive and moving it to land that is less productive. And I want to draw your attention to the final map I've got on the side here, that if you were to exclude agricultural land classifications 1 to 3, so that's kind of very good to kind of moderate grade agricultural land, then we're going to be kind of restricted to this low bioenergy pathway because there's simply kind of not enough land left that's close to locations that are good for bioenergy power stations to actually expand bioenergy. And you can kind of add all of these different restrictions. And again, we can start to look at how does this impact costs, how does this impact ecosystem services, and what are the impacts for the spatial footprint of the energy system. So that's all from me. I will now pass over to Brett.
Thank you, Gemma. So I'm going to briefly fill you in on where we're going now with this modelling capacity we have, particularly how we're starting to think about some of the issues that have been talked about in the sessions already about net zero, what this model can tell us about that, how we can quantify some of the issues that have come up. One of the things that we've got to realise is that looking at biocrops and renewables on their own is not the only thing that's going on as we push towards net zero. So integrating into this model expansion of forests as well. What you can see on this is a map which shows you, well, where will we put 700, 750,000, 800,000 hectares of forests are the targets we've got. This is what we need to do that. These are the best locations to put the forests. On the left-hand side here is where you might start putting BECCS plants. Not got a CCS network on there, I'll come to that in a second, but this is where you might put those. But when you see that those have both got to be done, they're both part of the strategies, we can see that we're getting land use conflicts. So one of the important things that this modelling allows us to do is to try and understand something about where those conflicts might arise as we're looking to deliver net zero through different types of land use change, both bioenergy crops and forests. So that's one of the things we've begun looking at as we expand this model more to examine net zero. The second thing we've been doing is trying to integrate a much more comprehensive assessment of CO2. So complete life cycle analysis of the greenhouse gas impacts of all this infrastructure development, of all the land use change. I'm not going to go through this in detail, but there's been a lot of work trying to make sure that we've got as much as we can of the CO2 in there. But it starts bringing up some quite interesting issues about how we should regard what we're doing. So in this diagram, what I'm looking at is different ways in which we consider the benefits that come from displacing agriculture. So one of the things you do is if you just ignore the fact that we're going to stop growing food on land, that food's going to be going produced somewhere else. But if you ignore that fact, it actually makes sense to get rid of lots of agricultural areas in the UK because they're high intensity. So putting biocrops, and that's what I'm looking at here, biocrops on this land, the green areas here are where we're displacing from grassland, from pasture land, the yellow areas where we're displacing from arable. Well, we really want to do that. It looks good because we're getting rid of high intensity, high CO2 agriculture. But if we start thinking about where that food's going to be produced overseas, it makes a difference. In the middle map, I'm just making some assumptions about the offset. The displaced agriculture is going to have emissions equal to the sort of the average UK. And on the left-hand side, we've gone in some detail to try and understand where we're currently importing the displaced agricultural crops from and the displaced agricultural livestock from, and thinking about the intensities of CO2 in those countries. So here we're looking at the carbon emissions, having carbon emissions overseas from the agricultural production that we've displaced. And you can see it makes a big difference about where we decide to do stuff in the UK. So these are important decisions when we're doing this modelling or thinking what we're going to do in the UK as to how we consider what's going to happen as a consequence of our actions here. What happens in terms of the CO2 that's displaced. So that's the second thing we've been looking at. The third thing and the final thing I'll talk about here was brought up in this morning's sessions as well. And that's that you can't really make these decisions about what's happening with land use and what's happening with the environment in isolation. There's a whole series of simultaneous changes that are going on that we need to understand. And this is just pointing out that if you're going to go down the route of BECCS, you've got to start thinking about, well, how are you going to connect that up to the CCS network? This is thinking about combined heat and power, and how are you going to put BECCS CHP, combined heat and power, in locations where you have the demand for those. And when you start bringing this sort of complexity into the models that Gemma's been talking about, and thinking about how we simultaneously develop a CCS network, a CHP, local distribution of heat and power network, then we completely change the locations in which we're thinking about making changes to land and therefore the environmental consequences. So really what we've got is a modelling platform which now allows us to explore some very complicated, interrelated problems. But these spatial models are absolutely critical in understanding the implications of net zero for the UK, for the land use change, and that when we start bringing the environment into these models, and the CO2 displacement and the flooding and all the biodiversity effects, it makes a big difference about how we might think about what that future might look like. Thank you.
Thank you very much, Brett and Gemma. I'd encourage you all in the audience and online, please start to put your questions through the Glisser platform, and we'll try and address as many of them as we can at the end of the session. So we've heard a little about the sort of terrestrial environment. Now I'd like to move to consider the marine environment. So I'm very pleased to introduce Professor Nikki Beaumont from Plymouth Marine Laboratory, and that's what she's going to talk about.
Thanks, Andrew. Great. So as Andrew's kindly introduced, I'm Professor Nicola Beaumont from the Plymouth Marine Laboratory, and I'm here to provide a little bit on the marine context. I should be very clear that my presentation today relies heavily on the work of my colleague, Dr. Stephen Watson. He's not with us physically today because he's expecting his first child any moment. So good excuse not to be here, but just to be clear, this work is very, very much linked to him. So my challenge today was to talk to you about the UK energy transition from a marine perspective, particularly looking at the challenges of undertaking an integrated assessment. As I'm sure you're all very aware, we have a significant energy resource off the coast. At the moment, around about 10% of our electricity comes from offshore wind. We are, however, expecting a really significant increase in the amount of energy from the offshore wind. This was further progressed in the British Energy Security Strategy, which was released very recently. This pushes us towards a position where we were actually looking to increase offshore wind by 5-fold by 2030. A 5-fold increase in 8 years. Now, this may not seem, it's hard to kind of conceptualize really what this looks like offshore. But it has been compared by some people to the initiation of commercial fisheries over a century ago. This is the kind of change we're looking at in our marine environment. I cannot get across to you how significant this is likely to be. Now, of interest, a lot of people seem to think there's actually nothing out there in that marine environment. Why do we need to worry? There's really nothing there, is there? It's just a big blue open space. Not the case. It's quite busy out there. For one part, there's a whole host of internationally important marine species and habitats. This may not seem particularly of interest to you. Birds and bees, fishes, not bees in the sea, obviously. Just making sure you're all awake. But also there's a whole host of users, everything from fishermen, aggregate extraction, the military are out there, cables are out there. It's a really busy space. In addition to that, the marine environment provides us with a whole host of benefits, things that you might not think about. The oceans take up 50% of our CO2. If we start to make these radical changes to our oceans, who knows what will happen to the amount of carbon dioxide which they take up? So when we're talking about this transition, I promised you challenges. I'm going to give you 3 challenges today. There are many, many more, but I only have 15 minutes, so I'm going to focus down on 3. The first one is the complexity of the landscape. Now, I'm sure everyone in this room is very familiar with bays. We're all very familiar with energy policy and all the activity in that area. Now, it's probably worth stopping and thinking that complexity in bays around energy policy, you should see what's going on in DEFRA around environmental policy. It's just as busy. It's just as dynamic. It's happening at a similar pace. One of the key issues that we're aiming for in terms of our environment policy is something called net biodiversity gain. And in terms of terrestrial, this is now in place. So developments we see on land have to aspire towards net biodiversity gain, which means that every development we see should be leading to us seeing an improvement in biodiversity, an improvement in our environment. That's established in terrestrial. In marine, it's a bit trickier. I'm a marine scientist, so obviously everything's always harder in the marine than it is on terrestrial, much trickier space. And so at the moment, we're working up what marine net gain looks like. But this isn't even in place. So DEFRA is working on this at this very moment in time. So it's an enormously complicated landscape. In accompaniment to this, we've got obviously the Fisheries Act and a whole host of policies related to all those other users which I just mentioned. Busy landscape. And this is at a national scale. Just imagine then if you layer on, as we do in energy, the complexities from an international space. So there's a whole host of international environmental treaties as well, which we have to abide to. Then look down in scale. Local policies, the complexity of local environmental policy mirrors the complexity of environmental local policy. So harmonising these landscapes, if you think about bays and how well people within bays talk to each other, give you all a minute to think about how well we know within bays conversations go. It's the same in DEFRA. They don't talk particularly brilliantly within the departments. Think for a moment what it's like trying to get them to talk across departments. So an incredibly complicated landscape. Now the second challenge, and I'll talk mostly about this one today, is understanding the impacts. I have had more conversations in the last 2 months about this than I can begin to tell you. Everybody says, well, it's benign offshore wind, isn't it? You put it out there. Doesn't it provide a marine reserve? Doesn't it stop trawling? It doesn't really have an impact, does it? That's what I want to talk to you about a little bit about today. Because before we can set up any environmental policy, we need to understand what the impacts of offshore wind are actually going to be. Think about that extent of the transition that we're looking at. So Steve Watson, he's been leading the development of a systematic map to really dig into the literature to understand what do we know about the impacts of offshore wind. Steve's also been looking at this from the construction perspective, an operation perspective, and a decommissioning perspective. He's also been looking at a whole host of other offshore structures, oil and gas, CCS, tidal and wave, to see if we can actually learn lessons from some of those as well. The systematic review that he's been undertaking actually builds on work that we've been doing at Plymouth Marine Lab and within UKirk, and with lots of people in this room, over the last 10 years. So we're not new to this space, but this is an up-to-date review. Going through the articles, we've got 153 to review. This is what the metadatabase looks like, just to give you a sense of the complexity of what's going on here. 153 articles, each, don't even try to read this. That's not the point. It's a picture to look at, not something to read. The 153 articles, each with a whole host of data points associated with them. So a huge amount of data pulled together in a metadatabase like this. The job then is to try and analyse this and try and put it into put it into a way that people can understand and it can be better communicated. So we're extracting the metadata at the minute in order that we can understand what the impacts of that offshore wind are in terms of ecology and also on ecosystem services. And there's a whole host of effects of the offshore wind. So as I was saying earlier, this is not a benign or passive technology. There's pile driving, drilling, electromagnetic fields, potential for collision with turbines. There's a whole host of potential impacts from these turbines being in position. And Steve's been looking at different visual representations. I'm going to give you a taster. This work is due for submission in the next couple of weeks, so it's a no Twitter affair here, please. But just I wanted to give you a flavour of some of the things that we were finding. Now this map shows you the distribution spatially of the studies. So this is the areas which the studies are looking at. And as you can see very clearly, the dark blue is where there's a lot of studies, green, fewer studies, and where it's grey, that means there's no studies. So immediately you can see a huge bias towards the Northern Hemisphere. Now I'm going to overlay this map with future aspirations of where we're expecting offshore wind to go. So the dark red areas are where we're looking at seeing really quite significant offshore wind development. The darker orange is slightly less and coming down to the yellow with fewer. And hopefully what this immediately communicates to you is that we've got vast tranches of the globe where we're pushing for this offshore development, and there's absolutely no studies of the impact at all. Absence all across the tropics, absence in the Southern Hemisphere. Now, for those of you who don't know about the marine environment, might all look the same, but it's really not. It varies every bit as much as terrestrial. So a marine environment in the tropics is completely different than one in the Southern Hemisphere or the Northern Hemisphere, far in the Northern Hemisphere or far in the Southern Hemisphere. So you can't just say something that's happening in Britain would be the same as what's happening in Brazil. So that's the spatial distribution of the studies. This, again, another figure. When we look at the impacts on the different species, and this chart is very much just about operations, not about construction or decommissioning. We're used to hearing, I mean, those of you who are familiar a little bit with this will be used to hearing about the fact that offshore wind generally has a negative impact on birds. We think we're not really quite sure, positive or negative, on marine mammals. Probably it's good for the fisheries and good for shellfish. And these are common messages that we're used to seeing. But what the metadatabase has allowed us to do is to dig into this into a bit more detail. So if you look at the first section, the top half, these are all different birds. And hopefully what you can see here, the yellow bars mean no change, red is a negative effect, and green is a positive effect. Grey is inconclusive. And what this is showing is the fact that, okay, maybe the overarching impact on birds is going to be -1, but it's hugely variable depending on the species. We've never really talked about this before. We've sort of had these generic, oh, it's bad for birds, it's good for fish. Actually, you can't say these things. It's really much more complicated than this, and it does vary really quite dramatically depending on the species. Another thing here that I draw your attention to, if you look, this line here is harbour porpoise. In this case, you've got 5 studies. Some of them saying it's positive, some of them saying it's negative, some of them saying there's no change, one of them saying it's inconclusive. This is how muddied the picture is. It's really complicated. So be really conscious when you see these statements about offshore wind is good or bad for this species group or that species group. It's a lot more complicated than that. Now this goes on because I'm actually an economist by training. So I see that ecological data, and there's a part of my brain that goes, oh, that's pretty tragic about the marine mammals, but actually, really, who cares? Sorry, it's brutal, but it is in my training, so I can't do a lot about that. So what I'm interested in is why should we care? Like, should we care? Is it important? And this chart really starts to hopefully explain why we should care. Along the bottom here, this is divided into two sections. We have construction on this side and operation on the far side. Along the bottom, we have those species groups I was mentioning before. So we've got, for example, birds and fish and humans. If we read up, you can see it's most useful. There is a laser. Great. If you read up here, you can see for the birds, there's generally red boxes reading upwards, which is those negative effects we mentioned. For the fish, if we read up, there's more positive implications, which again we mentioned. So if you read the table that way, it shows you the implications for the different species group. However, if we read the table across, what we have here on this axis is the ecosystem services. So these are the benefits that we get from the marine environment. The top ones are the provisioning services we get from the marine environment. So this is the fact we get our food from the marine environment. The second one are what we call our regulating services. And this is the fact that the environment does loads of stuff for us. It takes up our waste, it takes up our CO2. The next box is our cultural services. So this is the fact that we use our environment for recreation, for heritage values. And the final box down here is really focused on biodiversity. So if we read across now, we can see that when it comes to our provisioning services, so the food we get from the marine environment, you can see these are negative implications for the food we're getting. You can see that there's negative implications for the carbon being taken up. Now, this is really nascent data, but it does look like there could be negative implications for the amount of CO2 being taken up by the oceans if we put these structures in place. If we read across here, we can again see that from an ecosystem service perspective, you can see where the negative implications are likely to be. And here for biodiversity, a real mix of positives and negatives. So what this is hopefully communicating is the fact that this is why we should care, because there actually are really significant implications for us, for humans on land, from these developments. The other thing that's quite interesting in here is the confidence. So here, we've scored it on a 1 to 5 basis on the amount of confidence we've got based on the number of studies. Most of these boxes have got 1s and 2s, which means there's maybe 1 study, 2 studies, 3 studies. That's all we know. So just to sort of run through some of the key data gaps. The first thing is, you'll have noticed what I've shown you there was about primarily operation, tiny bit about construction, absolutely nothing about decommissioning. Now, we will have to decommission offshore wind. I think this often gets forgotten about, but you know, they have about a 20-year lifespan at the minute, so it's going to need decommissioning fairly regularly. No studies at all on that. We don't know what that looks like. Very little on construction. The other thing is floating wind. So we're driving at the minute. We're looking for a big increase as well in floating wind. We have no idea. There is no studies at the moment on the floating wind. Another one is the multiple or cumulative impacts. So a lot of these studies are done on the idea of one wind farm or one turbine. What happens when you multiply what we have already by 5-fold? We have no idea what these cumulative pressures will look like. Like I said, we're missing those tropical studies all across the middle of the globe. There's gaps in some of the taxonomic data. Some of the species we know nothing about. We know really very little about the regulating services. Think about the oceans. They take up 50% of our CO2. What will happen to that? We don't know. And most of the studies are actually limited to the immediate spatial impacts. We don't really know much. We don't do a huge amount of research into where this energy lands, or what happens to the cabling. Another point that's quite interesting is that we hear a lot about how public are very accepting of this. It's interesting how keen the public are, and it was interesting in the strategy recently. Onshore wind was really negatively perceived because people don't want it in their backyard. People are very keen to have this over here where they can't see it. But there are some people who are quite anti this. The fishers, in a lot of cases, are not very keen. And also you do wonder if people were properly informed about what the implications of offshore wind are, would their actual opinions be somewhat different? So we need a lot more focused assessments going forward. We are working to develop a tool to communicate a lot of these findings to stakeholders at the moment. So what you're seeing today is a first taster, and we're looking to get this in a position where it's much more visually accessible. So that was challenge number 2. I spent a long time on challenge number 2 because it felt really very important, because next time somebody says to you, is there any impact of offshore wind? And you go to tell them it's benign and we don't really need to worry about it. Hopefully some of that will have made you think twice. The third challenge I wanted to share was about understanding the trade-offs with other options and this need to take a whole systems approach. And this is where UKIRK is fabulous. And Gemma mentioned the work that we're doing on this as well. So one of the things that we see is this push to move the energy offshore because we can't see it and we don't know much about it. But actually we need to be able to balance that with onshore wind, solar. What does it look like when you put the system together as a whole? How do we actually make the right choices? And I think that's a really important thing, because we don't tend to consider these things holistic. We don't tend to think of the system in a holistic way. So, in summary, I've given you 3 challenges. There are many, many more challenges, but like I say, 15 minutes. So, but happy to talk about the other challenges as well. And my take-home points for you, there's 2 take-home messages here. The first one is that if we're going to secure a sustainable energy future, then we really need to be coupling our energy systems with our understanding of the environment and also social systems as well. The second take-home point is there's a chance for a win-win here. I get very tired of people being negative about environmental research because they think of it as a barrier. They think, oh, it's just going to stop us developing. It's going to hold us back. It doesn't have to be that way. It can actually be a positive thing. We can get ourselves into a place, if we do the right research, where the offshore wind is going in place and it has co-benefits. It actually has a positive effect on the biodiversity. It has a positive effect for fisheries, but it needs thought. It's quite troubling when you think that 5-fold increase I said at the start, that's got to be done in the next 8 years on the basis of the understanding that we have at the moment. So finally, I'm always happy to talk about this. Very welcome any questions. And also Steve has written a really nice blog on this, which you may be interested in reading. And that's all for me. Thank you very much.
Thank you very much, Christina. Can I have our speakers up the front? And we have about 18 minutes for some questions. There are quite a number. So I hope you're feeling clever, because there's some quite interesting questions. So I'll start with the most popular one. So this has got 6 votes. Can we justify using land to grow biocrops at all when our food system is already so insufficient in feeding the nature, especially when global food supply chains seem more vulnerable than ever? So I don't know, Brett or Gemma, if you feel brave enough to tackle that.
Yes, but we need to know the trade-offs. Yes. I mean, I refer listeners online here to the answer that was given earlier by Rebecca, which I think is the answer. Is there are good places to do things. It's not necessarily the case that we want to be growing biocrops in the UK, but there might be good places to grow biocrops in the UK. We also might want to be importing food from overseas or importing biocrops from overseas. And I think the analysis that we've talked about today begin to give us some idea of where it's efficient to do things. So we don't want to be just displacing agriculture in the UK for biocrops. We've got to think whether it's good to do that, and some of the analyses that we've presented today do actually give you some insights into whether it's good to do that. So there's trade-offs. Yes, I think we do want to get rid of some agriculture in the UK, and biocrops might be a good thing to do there. We have to think about where we're going to get the food from and make sure that we're not just displacing the problem.
Okay. The next question is for Nikki particularly. How likely is it that we will achieve the 5-fold increase in offshore wind? There seems to be a lot of investment in it at the moment. Is it feasible?
Very good question. Personally, I think there's risks definitely associated with our capacity to do that. I mean, one of the challenges that I didn't talk about was our skills base, and I know that was discussed this morning in the session, is do we actually have the skills available to be doing this? Another challenge is related to our ports. Do we actually have the ports available to actually get this stuff out there?
Another challenge is our onshore infrastructure. So we might be able to get those turbines out in the ocean, but actually can we then get the energy back onshore? And is the infrastructure ready for that? Again, another big challenge. So I think there's a lot of risks associated with that and a lot of challenges to overcome.
Okay, so now a question for Christina. In Germany, for those who oppose renewables near them, what alternative technologies or approaches do they tend to support?
I don't think they really argue about alternatives. This is a very specific movement, and they are suing. We have some weaknesses in our spatial planning law, which they are using for opposing the official spatial planning. And there is research about who is suing, or there are numbers about that. These are not usually the big nature conservation NGOs, but they are local citizens and even driven by certain political party interests sometimes. So the majority, 80% more, of the German population supports the energy transition and climate change policies, but it's a question of the local dynamics, and we try to break this dynamic, or we are trying to break this dynamic with this energy game, and it seems to work.
Okay.
I say it seems because we haven't.
You're still evaluating it.
Yeah.
Okay, here's a good general question. Should we expect some environmental losses to meet net zero? If so, what do we choose? Gemma, do you like to have a go at
To me, Andrew.
Yes.
I mean, it's difficult, isn't it? There's always going to be a balance between these things. We know that we need to achieve net zero. We might see, for example, some visual disamenity, for example. And I think visual disamenity is often is one that people often kind of bring up. Like, you know, you were saying in Germany, people don't like the visual disamenity associated with wind turbines, for example. But there's always, if we don't do that, what are the other options? Like, are we going to have loads of BECCS? Like, there is always another aspect. So it's getting that balance right. So I think focus on minimizing the adverse environmental impacts where we can, maximize co-benefits, but as always, it's going to be a balance.
Correct.
I mean, one of the things that's coming out of the work that Gemma's been doing is that for BECCS and afforestation as strategies for net zero, you can find locations in which the environmental benefits are positive. So we've got to remember what we're displacing, which is often quite intensive agriculture, which generally isn't great for water quality, isn't great for flood protection, it's not great for biodiversity. So when I talk about there's efficient locations in which to do things, there's certainly locations in the UK where it would make sense to get rid of the sorts of agricultural practices anyhow. So I think there are some win-wins on this. It's just we've got to be very careful in implementation that we're doing things in places which deliver those environmental benefits and not getting rid of agricultural land, which isn't so bad, but is also really useful for food production.
Yeah, for instance, in Lower Saxony, we found that there is even a very nice interplay between if we would put PV in the areas where we have a nitrous, too much nitrous in groundwater, and agriculture is the cause of that. That the farmers could have an income alternative in putting ground-mounted PV in these areas and grassland beneath. This is and we have in PV, we have very high or projected high revenues per hectare, which could even compete with animal husbandry, for instance, in Lower Saxony. So this could make a very nice synergy.
Nick Pidgeon would probably be better to make this comment. I've got to be a little bit careful where I'm going here. But one of the things is when you're talking about things like visual disamenity and the way people regard landscapes, is that changes. We know it changes. So it's not clear that the sort of objections that we see in the short term to the development of these renewable technologies will last in the long term. We haven't got enough, well, that I'm aware of, understanding of how it changes and how we get the right dynamics in place to make sure that people regard these things positively. But I think if we were careful about that and got the people who really know what they're talking about to help us in making those cases, that you could see these things as being seen as positive additions to landscapes, not always negative.
There's a paper published a number of years ago now by a researcher at Sheffield University, Paul Selmans, called Learning to Love the Landscapes of Carbon Neutrality.
Yeah,
That's exactly.
you've done work on this as well, haven't you, Andrew?
Yeah, so that's exactly the same point. Right, next one. This is a question, I think, particularly for Nikki. Should we in the global north be funding studies in environmental impact of offshore wind in lower income countries which are contemplating their deployment? So this is your Brazil and India type issue.
I think that knowledge exchange is absolutely crucial because it's a global issue. So we have to put resources, we have to put energy, if you excuse the pun, into making sure that those studies are undertaken. So in my opinion, yes, I think that we are incredibly introspective at the minute, particularly as a country. And, you know, we have previously seen research that has been driven to do those studies and to share knowledge globally. And I would like to see a shift back to that. So yes, in my opinion.
Okay. So here's a sort of general question. What types of policies would help avoid the land use conflicts we might experience going forward? What sorts of measures or initiatives could we take to try and address some of these sorts of issues? Christina.
I think that it is really important because we have this competition about land and space, because we have different land uses which are competing: recreation, agriculture, renewable energy, and so on and so on. We need some spatial planning here to resolve these conflicts and to choose the most efficient land use, because the market does not do it. This is the experience. And also, as to landscape aesthetic, I would say we need to include that, even if that changes. I completely agree with you. In Germany, the surveys say that younger people, they are more favorable of renewable energies in the landscape than older people. But on the other hand, the German population, or in the surveys, it shows that iconic landscapes with which people identify very much, they don't want even any change in these landscapes, even if they don't visit them. They want they want to know that this landscape, and I don't know whether we have been to the Lüneburger Heath, for instance, this landscape shouldn't change. And so this is also something, I think, which is culturally important as a cultural ecosystem service, and which should be respected.
I think the other really important thing is that the policies are integrated. So too much of the policy we see at the moment is divisive. So is the earlier question is, do we take energy or do we take environment? These should not be conflicting objectives. They should not be conflicting policies. We keep putting ourselves in this situation where we're vying against each other. Whereas actually, I believe that if we can actually evolve these policies collectively, they'll be much more positive. And I think those win-wins that we talked about earlier are in fact possible.
Yeah, I was just going to add to that. Again, kind of linking back to the bioenergy section earlier. If there were incentives in place to grow bioenergy crops in locations that did have co-benefits, we would start to avoid some of these land use conflicts, because we'd be targeting renewable energy infrastructure to locations where we know it has benefits. So yeah, but currently the government just haven't got those, so we're not seeing any kind of increase in bioenergy crops and things like that.
Right. Just picking up on Gemma's point, and a point that was made earlier as well. I mean, I'm just an economist by training, cards on the table. The answer seems pretty obvious, is that you've got to get your carbon pricing right. If you get that right throughout I don't think we should be expecting government, sorry, Gemma, because I don't think we should be expecting government, this was said earlier, government to pay incentives to farmers to do things. I mean, that's taking money out of general taxation in order to, and you've got this massive subsidy system coming in, which is trying to push things around. If we got carbon prices right, and if we got some of the externality prices right, that would go right the way through the economy. So that would mean that you would then have value from growing biocrops because of the carbon saving. That would mean that people who are developing BECCS technologies and BECCS plants would be able to make money from that because the carbon price is right. That gets everything right the right way through the economy. So if we could do that with our own country and start pricing carbon into everything, everything would work so much better. We also have to think about what's happening at the border and the adjustments we need to make to products coming in, energy coming in, or food coming in. Unless that's corrected, we can just displace these things overseas. So the problems, we know what to do. We've just got the political nous to get forward and do it. I mean, it's difficult. But if we've got that carbon pricing right, I tell you, everything would work so much better. We would overcome all these problems.
Christina, can you say something about because you've done this study in Germany. I know you've had some quite interesting political comeback on it. You want to say a little bit about your experience with that?
You mean why in Germany so little happened over the last decade?
Yes.
Yeah. One point I already mentioned. I think one thing is, for instance, ground-mounted PV has not been, or the whole PV sector has been discouraged over almost a decade. And probably the reason, I can only have suspicions about the political motives, but one thing is that, of course, the big energy companies, they are more in favor of wind, because this is a big investment, and PV is, especially on rooftops, is something which everybody can do by himself, and the control of this whole thing is not easy. They have to provide the grid, so there is cost. So I think that the big energy companies, they influence the political landscape. I already mentioned the farmers who disencouraged solar energy, and yeah, I think those were the drivers behind this that energy policy was so renewable energy were not more promoted. Now we have a two green ministers in the government who are driving very much forward, almost now again forgetting about biodiversity. So it's really policy, and I think Caroline Kuzemko mentioned that yesterday. Policy needs very fast success in 4 years' time or something like that in their election periods, and that is one of the big problems we have to tackle. We have to cut our recommendations into small pieces which can be achieved in one election. And bioenergy, by the way, was so seducing because it was a simple technology which was at the hand in already developed, while the other technologies had to be still developed. And if you set on bioenergy in this country, you have to make sure that you have very good life cycle assessments for the import of bioenergy from countries abroad, which is one of the main things which we didn't succeed in implementing. We have demands, but not the implementation did not work.
Okay. So that leads very nicely on to the other question that's top of the charts at the moment. This is a question, it's addressed to Gemma and Brett. What's your response to the German position on bioenergy crops? Is the UK misguided in its bioenergy ambitions?
I guess the point I always go back to is that bioenergy with carbon capture and storage comes up. And I mean, we've talked about it in previous sessions. It comes up as a key technology that we may need to use to get those negative emissions. If we don't have BECCS, we'll need to use another kind of negative emission technology. So I'm kind of interested, to ask Christina, what is Germany doing if they're not focusing on BECCS as an option? What are the other kind of negative emission technologies that they're considering?
Negative emission, we are occupied by by not having positive emissions. So
fair enough.
and of course we have 1/3 of the German territory is forest. So this is a big storage And we try to have longer times in, how would you say that? To leave the wood longer time in the forest, and then when we harvest, to store it in furniture and houses. So that's also a storage. We try to re-wet our wetlands, which we drained during the last decades. So there's a special strategy now by the Ministry of Environment to do that, and 4 billion euros is set on that for the next 4 years. So that's what's going on right now.
Okay. Well, thank you very much, everyone. I think we will have to draw the discussion to a close there, but please can you join in me in thanking our speakers, and I hope you found it interesting.